Well, welcome back. After all of these nice snow days, I think it's time that we get started in our new unit, which is going to be formula writing, and later on we're going to start balancing some equations. So to get started, I wanted to somehow get us up and running with doing a little video here so that you can do some of these on your own. We are a week behind in our schedule, so therefore if you were to look at this video, hopefully it will help you do some of the homework on your own, and then we can kind of continue on in class if you have further questions. So for this unit, at least for the next week or so, and to help us get caught up, we're going to do virtually a flipped classroom, meaning that you are to watch your videos at home and do as much of the homework at home as possible. You will have due dates throughout the week, and just make sure that you are aligning your week to maintain those due dates. Okay, so to get started, this new unit that we're going to be dealing with is naming formulas. Some of you may have started this a little bit in your physical science class in the past, or you probably stopped here depending on what middle school you went to. So I've been hearing from some of you, oh, Miss N, this is kind of complicated. So I just wanted to break this down into what I think are 5 very easy to do little regions, okay? There are 5 major types of compounds that we're going to be studying here in Chem 1. And the first one that we're going to do in this actual video are called the type 1 binary compounds. Now everything that we're going to be looking at today are ionic. That means that you're going to have a metal coming together with a nonmetal. So there's going to be a transfer of the electronegativity. Okay, so later on I will have other videos coming up where we will do type 2 binary compounds. They will also be ionic, but some of you might be wondering, hey Miss N, what do we do with some of these metals that are found in the D range? Well, this is their turn. Okay, so we're going to learn how to do those a bit. In addition, we're going to look later on in the week at the type 3 molecular compounds. These are going to be all covalent compounds. And then we're going to get into what may be considered a little bit more of the complex type of compounds, the polyatomic compounds, and then naming some acids. So let's get started with today. We're just going to focus on this first type here, which are the type 1 binary compounds. Okay, so we're just going to be looking at these today, and we will come back to the rest later on. Okay, make this into easy chunks. Okay, so the first one here. Again, I said these are going to be ionic, so that means that we're going to be having a metal with a nonmetal. Okay, so whenever we're doing this, as you recall hopefully that the metal is called the cation and the nonmetal is the anion, you always name the metal first. Okay, that's the cation. It's always named first, and you use his entire name. Okay, the nonmetal is going to be the one where you're going to change the ending a little bit. So let's look at this first one here. Sodium we know is the metal, okay? And if you remember from our oxidation numbers, it's down in group 1, which means it's going to be a +1 for its oxidation. So it's going to come together with iodide. Well, if you're looking at iodide, hopefully you can see it in group 7. In group 7, if you recall, its oxidation number is a -1. Okay, now the goal for these is to make sure that the entire compound that's coming together has a net overall charge of 0. So if we put sodium, which is a +1, together with iodine, which is a -1, if you take a +1 and a -1, you get 0. That means that this is a balanced ionic compound. Okay, your goal is to make sure that you're achieving 0. If you achieve 0, then these two will indeed come together. They will form an ionic compound, and we're going to name it like this. You're going to say the entire name of the metal, sodium. That does not get changed. That's your cation, gets names first. And then you probably saw it on the periodic table as iodine, but notice how the ending gets changed in these type 1 binary compounds. Instead of the INE, you're going to switch everything to an IDE. Okay, so it's going to have an "ide" at the end. So once these come together, you have sodium iodide. And make sure you check your oxidation numbers to be sure that they definitely balance out. Okay, let's go over here now to calcium. Calcium is in group 2. That means that its oxidation number is a +2. Okay, And oxygen is over in group 6. And if you remember, I had you guys all label the top of your periodic tables for these oxidation numbers, and that's going to be a -2. Well, check this out. A +2 and a -2 equals a 0. So that's good. That means this is going to happen, okay? So calcium, it gets named first. That's your metal, okay? And then it's not going to be oxygen anymore. You take the root, which is ox, but then you change that ending to an ide. So this comes together to form calcium oxide. Okay, these aren't too bad. So just to sum this up, we want to, in this unit, learn about binary compounds, and we're going to be looking at the metal and the nonmetal. Later on, we're going to be dealing with compounds that are just nonmetals, and then we're going to summarize all of them as the week goes on. Okay, once again, here are our type 1 binary compounds. We're going to talk about type 2 later, so just want to review this one more time. Let's just focus on this column right here. We're going to come back to this column later on. So sodium, whenever it's just sitting there as an element on the periodic table, looks like this. When it's ready to bond, it dumps off its electron and it becomes more positive as a result. It's ready to bond, okay? Same with cesium, and that has also an oxidation number of a +1. Just look at your groups to find out where I'm getting these numbers from. Calcium is in group 2, so there is its oxidation number. And if you look at aluminum, it's in group 3, so there's its oxidation number. We need these oxidation numbers later on whenever we are naming these, so you have to keep these in mind. Okay, let's go here to our next slide. Okay, this is just, once again, a couple common metals and nonmetals that you're going to see. Remember, these are all your cations. They're going to be all positive, and your anions, which are going to be all the negative. You can say the entire name. I'm not going to bore you and name every single one of these, but if you want to, you can always pause these and just take a look at some of the more common cations and anions that we will be using in Chem 1. Now, of course, there are others, but this is some of the more common ones, and you should probably start memorizing these a little bit so that you're not always looking at that periodic table that I gave you. Okay, and remember, whenever hydrogen could be both a cation and an anion, if it's serving its purpose as an anion, then it's going to be named hydride. Okay, and that'll happen sometimes. Fluoride, chloride, bromide. Notice that all of the endings here end in IDE. Okay, that's the big thing to take away from this. Okay, once again, here are your rules. Some of you need these rules. Keep these handy. So the cation is always named first, the anion named second. A simple cation, which is obtained just from a single atom, takes its name for the name of the element. So sodium, you're just going to give it its full name. And then you're going to take that simple anion by taking its root and ending IDE. And then write the name for the compound by combining the names of the ions. And at the very end, make sure that your overall charges balance out to be 0. Okay, now we're going to name a few. We're going to do a couple more of these in class 2. I have these all ready to go, but they are here for you, and I would like you to continue to name some of these on your own, and we'll check them over in class. Okay, so if you see here, I have your periodic table. Feel free to use this whenever you need it. I'm not really sure if it'll let me write on it because it wasn't earlier. Yeah, it's going to let me write on it. So again, these are +1, +2, +3 for oxidation number. I said this could be +4 or it could be -4. This is going to be -3, -2, and -1. You need these numbers, okay? So keep this periodic table handy. And let's get back and name some of these. Okay, sodium. Well, I'm going to go check it out. Sodium is here. So it's going to be, and I do this at the beginning while I'm getting used to this. Okay, so that's going to be a +1. And then Cl is going to be a -1 over here. Okay, so just write these oxidation numbers up here. That comes out to be a 0. Good. So we're going to name it. You're going to put sodium first. You're allowed to say his whole name. Instead of chlorine, you're going to put chloride. Okay, these aren't so bad, right? Now you might be wondering, what is this? Okay, this is important now. First, we're going to go check out aluminum. If you look at aluminum here, look what group it's under. Okay, it's going to be a +3, so put that. All right, chlorine is a -1. Okay. It takes 3 of these chlorines to balance out with this +3, so it gets a net overall charge of 0. If you have this 3 and you have -1 times 3, that comes out to be a -3. +3 minus 3 equals 0. You have to have a 0. So it takes 3 on this chlorine to balance out with that charge of that +3. And we're just going to name it now. Okay, this is aluminum chloride. Okay. Okay, so Ki is going to be a +1 and a -1. That equals 0. That's good. So this is going to be potassium iodide. Okay, let's look at calcium sulfide. Let's go over here. Calcium is over here with this +2. Okay, let's go back here. Okay, and let's look at sulfur, which is at a -2. Alrighty. Notice how they equal out to 0, so that's going to form. So now we just name it. Calcium gets its whole name, sulfide. Okay, these are the simplest out of all of them, the type 1 binary compounds. There's not too much to these, okay? CSBr, well, let's go look at our periodic table. Cesium is here with 1, and then bromine is here with a -1. I'm going to put them together. So we have cesium, bromide. Instead of that bromine, we switch it to bromide. Okay. Let's go back. Magnesium is a +2. Oxygen is a -2. That's going to form +2 and a -2. They balance out to a 0. Good. And now we just name it. Magnesium. See, these aren't too bad. Oxide. So what I would like you to do now is finish these up. Okay, let's just take one more look. Well, we'll do 7 and 8 together just so that you can understand that. So magnesium, if you go again to the periodic table, magnesium is a +2, right? You see it. Okay, so we're going to put that down here. Okay, and iodine is over here at -1. Okay, so this isn't balanced the way it is, right? You have a +2, you have a -1. So for this to occur, you have to have 2 iodines for that 1 magnesium, so it balances out. So now you have 2 times the -1, that's -2, right? With that +2, that gives you the 0. So that's going to form, okay? But it needs 2 iodines for that to happen. So now you just simply name it magnesium iodide. Okay? Same with calcium. That's our +2. -1, so it takes 2 of those to equal out. And now you just simply name it calcium chloride. Oops. You might be wondering, like, Miss Ann, why do I have to keep like balancing these out? Well, it's good practice for whenever we do it later on with our next one. They're more complicated. Now this is just a load of fun. Hold on, I want to do this one with you guys real quick before we jump off here. Okay, so we have aluminum. And then this isn't a typo, that's carbon. Okay, so this is fun. If you go here to aluminum, look at that, and it's a +3. Okay, it's, oh darny. Hold on, let's move this down again. Okay, I might not be able to keep going back and forth, so just trust me here. So this was a +3. Carbon, remember that group I said could be a +4 or -4? Well, it's going to be a -4 because it's named second. Okay. So you might be like, what in the world is this? Okay, well, we have to do what's called the crisscross method, I guess, if you want to say so. Okay, so it's going to take, if this is a -4 and this over here is a +3, we're going to have to get a common denominator here, okay, for this to have balanced out appropriately. So if you take this 4 times 3, that came out to be a +12, right? And if you take this -4 times 3, it came out to be a -12. So that worked. That came together. You still name it aluminum. Now this is carbide. Okay, That's hard. That took on an anion. Normally, you see carbon as a cat, or well, not even a cation, but usually you see it with your nonmetals. But this time, it actually took on the place of being a -4. Okay. So this comes, like I said, in handy later on whenever we start naming the type 2. So I just want to get you in the habit of naming these charges and making sure they balance out correctly. So you give these a try, finish them up on your own. Okay, you have all the way down till number 30. Be ready to go because we will be looking over these in class whenever you get to class. In addition, what I would like you to do is go to your, let me see, modules here. And then this is a PDF file of what I just showed you, so feel free to use it at your leisure. It's all of the naming compounds, so for those of you that get it and want to keep moving ahead, go for it. There's your PowerPoint that I'll just be talking over anyway. So whenever you are ready and you have finished those that I just gave you for practice, this is going to be your homework. Notice it's type 1 and type 2. We did not do type 2 yet, so make sure you keep it handy. You're going to turn the whole thing in whenever you finish the whole one, the whole complete worksheet. So you're just going to do the type 1 so far. So notice how it's just 1 through 10 here, okay? And then it's from 11 to 21, okay? So this time you were given potassium iodide, you have to actually write in the chemical compound, which would be Ki. Okay, so you have what you need here. Go ahead and practice these and we will go over them in class. I will see you guys soon.